Hello everyone, this is Stewart Taggart, founder of DESERTEC-Asia. Many of you have hotels to check out of and planes to catch. If you can't stay for my entire presentation, there are DESERTEC business cards placed up the back or available from the organizers. A video copy of this presentation is on the DESERTEC-Asia website. Prominent links will show you where. My sincere apologies for not being there in person to deliver this talk. Now, the topic of my closing plenary address is this: a clean energy vision for Asia. What I'll be doing is applying the DESERTEC Europe ideas to the Asian hemisphere. You can then decide for yourselves how applicable you think they might be. For those of you that don't know, the DESERTEC idea is quite simple. The amount of solar energy falling on planet Earth is so huge that if we could just harness a small amount of it, we could satisfy all of our energy needs. The best place to gather that sunlight is from the planet's desert regions where cloud cover doesn't interfere. For instance, the amount of sunlight that falls on just this tiny red speck in the Sahara Desert is sufficient to satisfy all of humanity's energy needs. Presented differently, as in this graphic at the lower right from the International Energy Agency, solar energy, that big orange area, dwarfs all other energy sources mankind can make use of, be they nuclear, coal, gas, or oil. In 2003, the German Aerospace Center outlined how Europe could make use of North Africa's huge solar resources. The plan involves building a series of concentrating solar power plants in North Africa as well as wind farms along the Moroccan coast. That energy could then both power North Africa's economies and generate a surplus that could be exported to Europe over high-voltage direct current power lines. The plan estimates that by 2050, 15% of the EU's electricity consumption, or 700 terawatt-hours per year, could be satisfied by North African solar and wind. The cost of all this is estimated at about $560 billion US. Energy generating technology amounts to 90% of that cost, electricity cables 10%. In July, global reinsurance giant Munich Re announced that it had assembled a consortium of European companies to study this idea further. If investment then goes ahead, Munich Re says North African electricity could be powering Europe as early as 2015. When you read press reports about the DESERTEC Industrial Initiative, as the European plan is called, a number of things usually get left out. I'm going to run through them quickly here. The first motive for the plan, of course, is battling climate change. That goes without saying. Number two is the looming replacement cycle of electricity generating capacity, predominantly coal-fired power plants. This doesn't get nearly the attention that it should. Take Europe. It is at the start of a huge wave of coal-fired power plant retirement. This at a time when its overall consumption of electricity is rising. The result is an ever-widening energy generation gap in coming years that must be filled with some kind of technology. Take another country, Australia. It is also at the cusp of a massive turnover cycle of coal-fired power plant capacity. It also faces rising energy consumption in coming years. My guess is that other OECD and reasonably developed non-OECD countries have similar looking charts. Number three, aging grids. These need both refurbishment and expansion. This is coming at a time when, number four, new renewable energy technologies are rapidly closing the gap to cost competitiveness. Taken together, the turnover cycle, the need for new grid investment, and advancing renewable energy technology is creating a once-in-a-generation opportunity, a perfect storm if you like, to make big improvements in our energy systems with minimal legacy problems. That's a big deal. Number five, energy security. The first of these is the peak resources debate. Whether or not you believe in it, it's something we should all think about. The second is the European Union's worries about overdependence on Russian gas supplies. The DESERTEC initiative was Europe's effort to find a plan B. A final element that virtually never gets covered in the press is that the DESERTEC Industrial Initiative offers an opportunity to foster economic development in the EU's North African neighbors. In addition to expanding concentrating solar power to foster catalytic economies of scale, the DESERTEC Industrial Initiative also is aimed at raising economic activity and incomes in North Africa. This creates richer trading partners, increases political stability, and hopefully will reduce the festering social tensions caused by boat people and economic migrants arriving illegally on the shores of Spain and Italy. In the press, the European DESERTEC Industrial Initiative is almost always portrayed as a technological renewable energy project. It is that, but it's also a lot more. This is relevant because it helps to more comprehensively cost the outlays and benefits of such initiatives. Now, let's get on to the real subject of this talk. Is the European DESERTEC Industrial Initiative relevant to Asia? In other words, do we have anything similar to an Asian Sahara from which we can reap huge amounts of solar and wind energy to power this region's rapidly growing economies? Let's start by looking at Asia's solar energy resources using 22-year NASA satellite data measuring direct normal radiation. Direct normal radiation, or DNR as it is called, is unimpeded sunlight hitting planet Earth unscattered by atmospheric moisture, dust, or other effects. As the legend shows, the strongest resources, 7 kilowatt hours per meter per day and above, are the darker reds and pinks. Looking at the map, we can see that the largest DNR resources exist over ocean areas where, unfortunately, they don't do much good apart from, say, growing phytoplankton. On land, North Africa and the Middle East win hands down for their abundance of DNR. Elsewhere, the southwestern United States has good DNR, so does northern Chile, so does northern South Africa, and so does Australia and northern China. So let's zoom in. This is a map of China. As you can see, it has desert regions in its north and west. Overlaying the same NASA data with 100 kilometer square resolution, you can see that northern and western China, as well as the area around Tibet, all have good solar resources. The orange areas, near major cities like Beijing, get around 6+ kilowatt hours per meter per day. That's generally considered the minimum to making concentrating solar power viable at current costs. Doing a rough overlay of the best areas of the country for direct normal radiation shows a wide area that can be developed. Adding a rough overlay of the nation's electricity transmission system, you can see that it goes to the fringes of this resource. For its part, the country's natural gas pipeline network penetrates deeper into the solar hinterlands than the electricity network. This is particularly true in the northwest, where gas pipelines connect Xinjiang to eastern cities like Beijing. In the future, such natural gas pipelines may provide handy rights of way for extending the electricity grid out to areas of high sun. Generally speaking, concentrating solar power is best exploited at latitudes of 35 degrees or less from the equator. Much of China's solar resources lie above that, and a good amount of it lies above 40 degrees north. That's a level at which the lower angle of sun may make developing concentrating solar power marginal. Despite this, the Chinese are building renewable energy parks in this band that incorporate concentrating solar power. This shows admirable determination for which they deserve justifiable credit. While China has significant solar resources, its true comparative advantage may well lie in wind. Huge wind resources exist in Mongolia and Inner Mongolia. Harvard University researchers estimate China could meet all of its energy needs through its terrestrial wind resources alone. But China also has significant offshore wind resources. That's because the East China Sea functions as a kind of wind tunnel, funneling warm equatorial air back toward Alaska as part of global atmospheric circulation patterns.